All right, this is 8.f, more with functions and equations. And linear equations, excuse me. Linear meaning line. More specifically, we're going to discuss point-slope form. So if I give you the equation or the general form for point-slope form, you ought to be able to take the slope, if given it, and a point, if given it, and put it in this equation and end in slope-intercept form. So you're going to start here. But to start here, you must have a point. So if I'm saying A is singular, you only need one point, and you must know the slope. And we know the slope is the m in the equation. Okay? It's always written as a fraction if we're talking about equations. If we're talking about functions and we call it the rate of change, it can be written as a decimal as well. If I give you, let's look at an example. Okay? And you got to remember, this is the equation you're using. Okay? That's point-slope form, or PSF, as you'll see me refer to it. The slope, which they'll identify as m, is negative 1/2. My point is 0.3. Well, I know that intercepts have an x or y value of 0. Since the x value is 0, this must be a y-intercept. Just a rule of thumb. If I'm looking at this point, that's my x, that's my y. I'm going to substitute the information I see here into that equation right there. Do I know what y is? No. Y comes down. y1 is the values you have right here. This is 0.1. So that's where I get x1 and y1 from. What is y1? y1 is 3. Equals, what's the slope? M is negative 1/2. X won't change, because I don't have just an x over here, but I do have an x1, and it's 0. Now, just get rid of the constants and all those extraneous operation symbols, and you want the y by itself. So to get y by itself, I'm going to box it. I don't want it to move, but I got to get rid of this negative 3. I get rid of it by using the inverse operation of subtraction, and that's addition. I add 3 to both sides. This is stuff you've seen before. These cross out. What am I left with? The y and the equal sign. What comes down? Negative 1/2 times x is negative 1/2 x, right? And then 0 plus 3 is a positive 3. I went from point-slope form to slope-intercept form. That fast. Now, I can graph it. If I'm graphing this, I'm going to use the Cartesian plane. Throw me a ruler. I'm going to use the Cartesian plane. And we've had exposure to graphing. I know that my rules of graphing tell me to begin with the y-intercept. Okay? This is my equation. That's my equation. Y equals negative 1/2 x plus 3. Let me go ahead and label this graph. This is the y-axis. That's the x. That's the origin. Putting some values on here. What's my y-intercept? Well, Mr. Gray, I'm still a little shaky with identifying the parts of a linear equation. Okay? We know that this y comes from the ordered pair. Like one of these. We know this fraction right here is our slope. We know this x comes from the ordered pair. And when you see that something comes from the ordered pair, that just simply means it won't change. It's going to stay a variable. Unless we're trying to find an ordered pair to check it, which I'll show you as well. And this 3 here is our y-intercept. Okay? Well, I've got to write that as a point. I can't just graph a 3. So 2 is to identify the slope. Step 1, we identified the y-intercept is 3. But to write it as a point, I've got to write 0, 3. Okay? Identify the slope. The slope is negative 1/2. Remember, the top number tells us whether we're going up or down. The bottom number tells us whether we're going left or right. If it's negative on the top, we go down. If it's negative on the bottom, we go left. If it's positive on the top, we go up. If it's positive on the bottom, we go right. We begin with the y-intercept. The y-intercept is 3, but I can't plot just the 3. I know that if I'm plotting an intercept and it's on the y-axis, the x value has to be 0, which is why I wrote it like that, 0, 3. I'm going to plot it. It says begin with the y-intercept, so I'm going to plot 0, 3. 0, 1, 2, there's 0, 3. Okay? After I've identified the slope, do rise over run now. That means go up or down, then go left or right. Okay? If I'm here and my slope is negative 1/2, what does this top number tell me?
You gotta go down.
I gotta go down once. Starting at my y-intercept, go down 1. Here, do I plot a point? No. I acknowledge the bottom part of my slope. It's a positive 2, so that means go 2 places to the right. 1, 2. I need to be aligned with this 2 right here, but I need to be exactly 1 space below my y-intercept. I go back to my y-intercept and do the opposite. So after you do rise over run, then do opposite. So I went down 1 and right 2. Now I go back to the y-intercept and go up 1 and left 2. It's aligned. Make sure it's lined up with the 2. Okay? And then draw my line. Put arrows on it. And if you're going to name this line, name it the equation. Y equals negative 1/2 x plus 3. Okay. Now, if you wanted to check this, I can take that same equation y equals negative 1/2 x plus 3, and we can call this C, checking or understanding. I can use the same equation. Pull a point from the line. What new points did we make? 2, what's that? 2, 4? It's right here. I'm at negative 2, and I went up 4. So that's a point that was on the line. And it has to be a point that's on the line. Here go another one. Positive 2, where's this one? Positive 2, 2, right? Take one of these points and plug it into the equation. See if the left side equals the right. I'm going to use this one. It's 2, 2. What do I plug in for y? 2, because this is y, and that's x. I do negative 1/2. What do I plug in for x? 2. and then bring down the plus 3. 2 equals negative 1/2 times 2. What's 1/2 of 2? 1. And then I add the negative symbol and add the 3. Does 2 equal negative 1 plus 3? Yes. So that point is a solution to that line. That lets us know that we graphed this line correctly. Not only did we graph it correctly, we used the right computation. Because the points that lie on the line, when plugged into the equation, the left side equals the right. 2 equals 2.